Ever gaze up at the stars and wonder if there's anyone else out there? The universe is a vast, sprawling expanse of cosmic wonder, teeming with billions upon billions of galaxies, each one home to countless stars. And around these stars, planets. So many planets, some of which are not so different from our own. In fact, scientists have managed to identify a multitude of these celestial bodies known as exoplanets, located in what's referred to as the habitable zone. This zone, also known as the Goldilocks zone, is the region around a star where conditions might just be right for life as we know it. It's neither too hot nor too cold, but just right for liquid water to exist. Given the sheer number of these potentially habitable exoplanets, it seems statistically likely that life, in some form or another, could exist somewhere out there. But if that's the case, why haven't we heard from anyone yet? This very question is what scientists call the Fermi Paradox. Now, you might be wondering who Fermi was and how he came about this paradox. Well, let's take a quick detour into the annals of history. Enrico Fermi, a renowned physicist, was born in Italy but later migrated to the United States, where he played a significant role in the development of the atomic bomb. But Fermi's contributions to science didn't end there. Oh no. He also had a profound interest in the cosmos, which led to a casual conversation that sparked the birth of the paradox we're discussing today. It all happened on a regular workday in the summer of 1950. Fermi, while having lunch with his colleagues, suddenly posed a question: where is everybody? His query wasn't about their lunch companions, but rather about the lack of evidence for extraterrestrial life. Considering the vastness of the universe with its billions of stars and potentially habitable planets, Fermi found it odd that we hadn't yet come across any signs of alien civilizations. And thus, the Fermi Paradox was born. The Fermi Paradox, in its essence, is an apparent contradiction. On one hand, we have the Drake equation, which suggests a high probability for the existence of extraterrestrial life, given the sheer number of stars and planets in the universe. On the other hand, we are yet to find any contact or evidence of such civilizations. It's like throwing a grand party, sending out countless invitations across town, and yet, when the day comes, no one shows up. You're left scratching your head, wondering where everyone is. This paradox is not just a whimsical thought experiment, but a serious question that probes the nature of life itself and our place in the cosmos. It's a question that has puzzled scientists and space enthusiasts for decades. And as we delve deeper into this mystery, we'll explore some of the potential solutions to this paradox and what they might mean for our understanding of life, the universe, and everything in between. To grasp the Fermi Paradox, you must first understand just how enormous the universe is. Now, when we say enormous, we're not talking about a long road trip or even the distance to the moon. We are talking about a scale that is almost beyond human comprehension. The universe is roughly 93 billion light years in diameter. That's a number so big, it's hard to wrap your head around. And within this incomprehensible expanse, there are an estimated 2 trillion galaxies. Yes, 2 trillion. Each a colossal whirl of gas, dust, and countless stars. To put it in perspective, every grain of sand on every beach on Earth would not be enough to represent all the stars in the universe. Each of these stars, like our own sun, could be the center of its own planetary system. Astronomers estimate that there could be more than 100 billion planets in our Milky Way galaxy alone. But let's take it a step further. If we were to consider that only 1% of these planets are located in the habitable zone of their stars, where conditions might be right for life as we know it, we would still be left with 1 billion potentially life-bearing worlds just in our galaxy. Expand that thinking to the estimated 2 trillion galaxies in the universe and the numbers become mind-boggling. We're talking about an unimaginable number of planets that could, in theory, host life. Now, we don't know for sure if life exists on these planets. Our search for extraterrestrial life is still in its early stages. But the sheer scale of the universe, the staggering number of galaxies, stars, and planets, makes the notion of us being alone in the universe seem almost absurd. With such an unimaginably vast number of planets, it seems almost impossible that we're alone, doesn't it? So why the silence? There are several theories that try to answer this. Firstly, let's explore the zoo hypothesis. This theory suggests that extraterrestrial life forms might be fully aware of our existence, but are deliberately avoiding contact. It's like we're an animal in a zoo, and they're the spectators, observing us from a distance. They've imposed a self-quarantine, if you will, to prevent any interference with our natural evolutionary progression. Sounds a bit like a cosmic prime directive from Star Trek, doesn't it? But this theory brings up more questions. Why would they avoid contact? Are they waiting for us to reach a certain level of development? Or perhaps they fear that contact could result in our extinction, much like how contact with more advanced human societies has often been disastrous for indigenous tribes here on Earth. Another popular theory is that civilizations might not last long enough to make contact. This is often referred to as the transience hypothesis. The idea is that technological civilizations could be fleeting. They rise, peak, and then fall, all before they have a chance to make contact with other civilizations. The vastness of space and time works against us here. The universe is over 13 billion years old, while human civilization is barely a blip on that timeline. Yet another theory suggests that we simply aren't listening properly or in the right way. This is known as the "we are not listening" theory. It proposes that extraterrestrial signals could be passing us by unnoticed because we're either not technologically advanced enough to detect them, or we're not looking in the right way. It's like trying to tune into a radio station, but you're on the wrong frequency. There's also the possibility that we're alone. Yes, it's a bit of a downer, but it's a theory nonetheless. This is known as the rare Earth hypothesis. It suggests that the conditions needed for life as we know it are so specific, so incredibly exact, that the chances of them occurring elsewhere in the universe are slim to none. And finally, there's the dark forest theory, which borrows its name from a science fiction novel. It suggests that civilizations might be deliberately keeping quiet to avoid attracting the attention of more advanced, potentially hostile civilizations. It's a chilling thought, isn't it? Each of these theories presents its own set of challenges and further questions. But they all attempt to solve the mystery of the Fermi Paradox. With so many potential homes for life out there in the vast cosmos, why haven't we heard a peep? Tune into the next scene as we delve into the concept of the Great Filter, another proposed solution to this cosmic conundrum. One of the most chilling solutions to the Fermi Paradox is the concept of the Great Filter. This frightening idea suggests there's a wall in the path of every civilization, a barrier so formidable that it prevents them from making a significant mark on the universe. The Great Filter, in essence, is a hypothetical event or stage in the development of a civilization that is incredibly difficult to overcome. It's like a cosmic test, a bottleneck that strains out civilizations, allowing only the most resilient to survive. It's a filter that might snuff out civilizations before they can reach out into the cosmos, effectively keeping the universe silent. But here's the real kicker. We don't know where this filter is. It could be behind us, in our past, meaning we're one of the lucky few to have made it through. Or, more ominously, it could be ahead of us, a future hurdle that we've yet to face. Could it be that we have passed the Great Filter, or is it looming in our future? The Fermi Paradox raises more questions than it answers. This paradox, named after physicist Enrico Fermi, grapples with the contradiction between the high probability of extraterrestrial life and the lack of contact or evidence for such civilizations. We've journeyed through the vast scale of the universe, pondered the numerous possibilities, and even considered the chilling implications of the Great Filter. What does this all mean for us, you might ask? Well, the Fermi Paradox is more than a scientific conundrum. It's a philosophical quandary that forces us to question our place in the cosmos. Are we alone, or just not listening hard enough? Are we the first, the last, or the only? While we continue our quest for knowledge, the paradox serves as a reminder of the mysteries that still elude us. It keeps us humble, curious, and ever searching. Until we find concrete evidence, the question remains, where is everybody?